Hello, I've just released a new SketchUp extension called Floor Generator SKP, and in this video I'll be going over some of its basic functions to get you started. Floor Generator SKP is a tool made for architectural visualization artists that allows you to generate realistic, 3D tiled patterns in a matter of seconds. Most professional ArchViz studios you should be looking up to are already using similar tools in their modeling workflows to achieve those clean-looking, detailed floors. PBR floor textures are fine when you're just starting out, but if you want to push your work further, this tool becomes essential. You can install the extension directly from SketchUp's extension warehouse, and once it's installed, you're ready to go. In this tutorial, we'll be generating a basic, standard running bond parquet floor. To start, select the face or multiple faces you want to generate boards on, then open the Floor Generator SKP UI from the toolbar icon, or by activating it from the Tools drop-down menu. The Floor Generator SKP UI opens with default settings, and the preview appears over the face or faces you selected. The UI is divided into multiple sections. We'll go through each section step by step. The Pattern section contains the most common pattern types. At the time of recording this video, there are 14 unique, fully customizable patterns available, with more coming in future updates. Since today we're generating a standard running bond pattern, we'll leave the pattern type unchanged. Feel free to explore other patterns yourself. Offsets and base rotation are fairly self-explanatory. You can also move and rotate the pattern origin directly in the preview by clicking on the blue and red control points. The seed setting controls all randomization. Using the same seed will always produce the same result, and the dice button can be used to generate a new one. Now, let's move on to the board dimensions section. Each floor pattern comes with its own set of board dimension controls. Board length and width define the size of the boards. By clicking the lock icon, you can unlock the max value. For example, if min is set to 60 and max is set to 120, each board will have a random length within that range. The same applies to board width. If you need more control, you can enable Advanced mode. This allows you to define exact board dimensions and the order in which they're placed. We'll skip this for now and cover it in a separate tutorial. I'll reset the settings now and move on to row offsets. Row offsets shift each row by a percentage value. Let's remove row 2 for now. You can see the boards forming a basic grid. Now we'll add 3 new rows and assign each one a different offset. I'll set row 2 to 33, leave row 3 at 0, and set row 4 to 66. This creates a more visually interesting pattern. The gap setting defines the spacing between boards. You can unlock the X and Y axes if you want different gaps in each direction. For this pattern, we'll leave it at 0.2. Board offset X and Y, along with rotation, work differently from pattern offsets. These settings apply small random transformations to individual boards, helping break up uniformity. We'll set all 3 to 0.05 centimeters to introduce subtle imperfections. This is an important step for realism. The tilt setting tilts boards sideways in 3D space. We won't be using it in this example. Next is the extrusion and finishing section. The extrude value controls how much each board is raised along the Z-axis. This isn't visible in the preview, since the preview only shows the 2D layout. I'll unlock the max value and set min to 0.95. It's a very subtle change, but it helps the floor feel less perfectly flat. Chamfer height controls how much the top edges of each board are chamfered. This is important for creating small edge highlights in renders. We'll leave this at 0.05 centimeters. You can also set it to 0 and rely on rounded edges in your render engine if you want faster generation and fewer polygons. Wavy edges introduce irregular edges on each board. We'll cover this feature in another tutorial. Now, let's move on to texturing. Click Add Empty Texture Row to add texture rows to the table. Each new row is assigned a random color, which is also shown in the viewport. If the texture field is left empty and we click Generate, the floor will be created using those colors. The weight value controls how frequently a texture appears, but we'll leave all values at 100. Clicking the plus button in the texture column opens a file browser where you can load a custom board texture. To speed things up, there's also a batch add feature that lets you import multiple textures at once. First, I'll remove the existing texture row by clicking the X button. Now I'll click Batch Add and select all the albedo textures. Using 8 albedo textures gives us plenty of variation. These textures were purchased from 3D Sky. A texture pack system is currently in development and will be introduced in a future update, along with some free texture packs. Each texture row can also include additional maps besides albedo, but we'll leave that for another tutorial to keep things simple. Texture orientation is best left set to auto and texture positioning to cover. Texture expand increases the UV area beyond the board bounds. I recommend not going below 0.05 as lower values can lead to visible seams when using lower quality textures together with combined textures. Combined textures is one of the most important options. When enabled, it creates a texture atlas from all the imported textures and applies it across the entire floor. This effectively turns multiple board textures into a single texture, making the material much easier to manage in your render engine. Texture quality is best left at raw, unless you have a specific reason to downscale the textures. Export textures and maps can only be enabled when combined textures is turned on. When enabled, the generated texture atlas is exported after generation. This is more useful when working with multiple texture maps, which we're not using here. Random texture position randomly offsets UVs within safe bounds, without crossing seams. I recommend using it together with random mirror X and Y to add even more variation. Project to chamfer faces projects the top texture onto the chamfered faces to maintain the correct UV flow. We'll leave this enabled. For side faces, leaving this enabled would cause warped UVs on side faces, so we'll keep it disabled. Override side faces and override source faces allow you to apply custom colors to those faces, for example to emphasize gaps. We won't be using those options here. Now that everything is set up, we are ready to generate. But before we do that, if you are using a real-time rendering engine, make sure you deactivate the Live Sync feature before generating, as active Live Sync will significantly slow down the generation process. Click Generate and wait for the process to finish. And that's it. We now have our floor. Since Combined Textures was enabled, all boards share a single material, but that material contains all 8 textures, each randomly positioned per each board. Let's take a closer look. As you can see, each board was generated individually, with subtle chamfers and correct UVs on each face of the board. And that's gonna be it for this intro tutorial. Make sure to follow the channel for more ArcViz content.